Hello everyone, my name is Peng from National University of Defense Technology. Today I am sharing our work, clone-based code method usage pattern mining. Firstly, let me introduce the background of this work. Sometimes developers may search code in code repository like GitHub, and then they reuse the result code in their own applications. However, different from the API in the third libraries, the result code may only have few usage examples and insufficient comments. So it is hard for developers to understand the usage pattern of result code, and they may misuse the result code and introduce bugs in their own applications. So in this work, we want to help developers to reuse the code correctly. For example, if a developer wants to search a method for getting images, he may achieve the result method named getImageStream and can find a usage example of it. However, it is hard for him to understand the usage pattern of method getImageStream from only one usage example. Then we find a clone method of the result method getImageStream. The clone method implements similar functionality of result method. Although the result method needs 3 parameters while the clone method only needs 1 parameter, they have similar usage patterns. For example, no matter result method or clone method, the developer should check the first parameter of them is not none. Moreover, the method getImageStream will always appear with method write.sourceToField and delete. So we find the clone code may have the same usage patterns, and this finding inspires us to search the usage patterns of the results not only from its usage examples but also from those of its cloned methods. Based on that idea, we propose an approach named looping to detect usage pattern for target method. Firstly, based on a target method, looping detects the type 1 and type 2 clone code. Then it collected all the usage examples from both target method and its cloned methods. Then it applied program slicing based program dependency graph to remove useless code and normalizes the relevant code in text, statement, and syntax 3 levels. In the last, it mines the usage patterns by frequent subsequence mining. We implement looping in a dataset including 50,000 Java projects. According to the syntax keyword in mined usage pattern, it can be divided into 4 types, including condition check, iteration, error handling, and method co-occurrence. Condition check refers to the constraint that needs to be satisfied before or after executing the method. For example, developers need to check the first parameter of getImageStream is not none. Iteration refers to the method should be used in a loop. For example, method readNext will only read the first line of field without the loop. Error handling refers to the routines that respond to an unexpected state of target method. For example, if there is something wrong when executing an encode method, the program will throw an exception and collect the message of exceptions. Some methods should be used together. Missing one of them will lead to a memory leak or visiting an invalid source. For example, method open brace and close brace should always appear together. To evaluate the precision of looping, we randomly select 100 usage patterns from each type and analyze the correctness of one usage pattern manually. We find looping performs better in condition check and error handling, but does not work well in the rest 2 types of usage patterns. So we still need to improve looping in the future works. Thank you.